Okay, today's lesson is Unit 6. It's lesson number 5, and you're going to be able to rotate figures on the coordinate plane after you learn what I'm showing you today. So, a rotation turns a figure around a certain fixed point called the center of rotation. We typically use the origin as the center of rotation because it allows us to turn the image one way or the other. We call that clockwise if we're going the way the hands of the clock actually turn to the right. We sometimes want to rotate counterclockwise, so as you can see, this part of the notes here reminds us that we could be turning backwards to create our images with a rotation. Also visually, okay, this little pentagon kind of is sitting upright like a little house would be, and this is the roof. Well, what you'll notice is when it is turned, when it is rotated, it is going to be sideways. This little roof here used to be pointed straight up. It's going to be pointed to the side, and that is something that you're going to want to notice when you're doing rotations to ensure that you really have rotated or turned the image rather than just reflected or slid over like a translation. So again, fill this part in. A rotation is a turn. Our center of rotation will be the origin, and we're going to rotate in increments of 90 degrees, okay? If you remember how the grid is set up, we've got an XY axis. A full circle would take our image 360 degrees. So if we divide that up into the 4 parts where we have these 4 quadrants, we have 90 degrees in this corner, 90 degrees here, 90 degrees here, 90 degrees here. So if you were to go full circle, there's 360. If you were just to go 90, it would turn you into the next quadrant, and then of course the next and the next. So all 4 90-degree rotations would put your image back to where it began. Remember we talked about quadrants the other day. If this is your XY axis, quadrant 1 is up here. If you rotate counterclockwise, you're going to land in quadrant 2 over here, and then counterclockwise again, quadrant 3 and quadrant 4. So if you draw a capital C on your grid, it's going to take you from the first all the way through to the 4th quadrant. And this is just helpful to remember what would happen each time you do a 90-degree rotation. You move from quadrant 1 to 2, 2 to 3, 3 to 4. If you're rotating clockwise, quadrant 1 shapes would rotate down here into quadrant 4. And then the ones here would rotate into quadrant 3, and 3 goes into 2, and 2 goes into 1. So it's just like one click to the right for a clockwise rotation, 90 degrees, or one click back if you're doing counterclockwise rotations. So with all that, we're getting our brains used to doing these. We have some images down here. What I want you to do in just a moment is pause this video, and you're going to go through these and see if you can come up with the degrees. See how it wants us to find the number of degrees in each rotation? I'll give you a hint to start this first one. The shape, this little pentagon that we've already kind of looked at, the A is standing upright. When it does its rotation, when it does its turn, we already talked about how this little roof is going to be pointing to the right. That's how we know that the rotation is happening clockwise, and it goes from the 2nd quadrant to the 1st. So guys, that's how you're going to know. It's only one click over. That's how we know it's only a 90 degrees clockwise, because that's the quickest way to get from your figure to the image. With that said, you could still rotate counterclockwise, okay? Counterclockwise means we're going to take this image, we're going to turn it this way, okay? Go the long way around to get to this image. So what that would entail is one turn, putting it down here, which would be the first 90. Then we would have to do another 90 to put it here. So 90 and 90 is 180. And then 180 plus a third 90 gives us the rotation of 270 degrees, but again, direction's important, okay? If I turn this way, counterclockwise, yeah, it's going to take longer, but I can still get there. The quicker way, remember, was 90 degrees clockwise. So again, pause the video. I want you to just take a few minutes to see if you can come up with the degree measures for each of these questions, just to give your brain time to process so that you get a chance to look at these shapes and to really wrap your head around what it means to rotate or turn each image. So again, pause the video, try these on your own, and then hit play. Okay, so here we are. We already talked about this one. It's 90 degrees clockwise, or going the long way around, it's a 270 counter. This one is shorter if we travel from here, this direction, up to the first quadrant. So you can see how the bee used to be standing upright on the original image. It's now sideways on the image. So that's how we know a turn or a rotation has happened, and it's only one quadrant change from down here to up here. So that's how we know it's a 90, but it's counterclockwise if we go the short way. It is also considered a 270 if we go this way. If we go clockwise, it's going to be click, click, click. It's like 3 clicks if this was like a dial that you could turn on your washer or your dryer or something. So 270 clockwise, 90 counterclockwise. This image down here gets turned completely upside down, and whenever you do that, you end up with a 180 degree rotation. Really doesn't matter if we turn clockwise or counterclockwise. Okay, it's both the same whether I go this way or this way, but it is important that you notice that it is on the opposite side of the grid from where you started, and that's always going to be shown if there's a 180. Alright, so towards the bottom, there was another 180 down here for number 5, and I hope you noticed that. It's the same sort of image or figure that gets flipped completely upside down and put on the opposite side of the grid, so that's how we know it's a 180. Clockwise or clockwise or counterclockwise doesn't much matter. It's still how you get there. This, though, I think is important to look at. Okay, it's a capital L, and it is turned on its side, so the L is actually sideways. So definitely it's going counterclockwise, and it's one quadrant change. So that tells me it's a 90 degree counterclockwise. But I could travel this way. I could turn it here, and finally land here with a 270 clockwise if I really wanted to go the long way around. Last one, you have the figure F. F is now stood up in the first quadrant, so I went from one quadrant to the next right next door. So it's a 90 degree clockwise or 270 counterclockwise if I go backwards. Okay, so far what you have is some basic information about rotations, what they look like, how we can turn, and also a little bit of information about the different quadrants and how when you rotate, each quadrant is important to pay attention to. Now, for this piece, we are rotating the figure shown. I've already attached the clear plastic transparency on top for you. This is going to allow you to turn the image and actually see what happens. So you may have to, mine's a little off here I see, but when you do this, okay, it's a little tricky to look at, but your original figure you can still see through the transparency like on my screen, but when you turn it 90 degrees clockwise, is the first one that we're working on. 90 degree clockwise rotation is exactly what we just did. We took the transparency where it was originally seated on top of the original figure, and when you turn it, you definitely see that the image, it used to have C pointing straight up at the top. C is now pointed to the far right, and that's going to help you tell that you turned it clockwise, and it went from the first quadrant to the fourth quadrant right next door. So that's how we know it's a 90. Our job here is to look at the coordinates and see if there is a pattern. So A prime, this image that we got when we turned our paper, is actually located one box over, but 2 boxes down. B prime is also located 1 box over, but it's way down here at -6. And C prime is located all the way over to 7 before it's down 4. So our job, it says, look for any patterns, try to create an algebraic representation. So an algebraic representation, we kind of looked at these when we talked about reflections. So if you notice what's happening, the points change, but not dramatically. The original point for A was over 2 up 1. Well, the image is now over 1, but it's down 2. So I think if you notice what's happening, you end up having to switch the X and Y values. But it didn't say that they were both positive. Remember, all your positive points are in the first quadrant. When you rotate, you're always going to be moving to a different quadrant. So the points in this quadrant have positive x values, but they all have negative y values, like the points we just wrote down. So remember, because we switched our values, these weren't originally our y values, they were originally our x's. See how 2 turned into -2, 6 turned into -6, and 4 turned into -4? So basically, if you have to write something down in words on what we're seeing pattern-wise, we actually negated our original x values, and then we switched our x and y's. So that's what this would look like on algebraic representation. The y value would go out in front. The x value that goes back here got negated. Okay, so we'll use this algebraic representation here in a little bit, but I wanted you to try to look for that pattern, and I wanted you to see what would happen. Alright, so for the next one, it says we have to do a 180. So I already had my transparency turned 90. If I do a 180, it should look like this on your paper. If you go ahead and spin that so that the triangle is completely upside down, C is pointed up in the original shape, a 180 would turn it completely upside down just like this. We're going to do the same thing. We're going to look at those coordinates. We're going to see if we can find a pattern. So A prime, let's see, it would be -2, down 1, -1. And B would be -6, -1. And C is only over 4 and down 7. So there should be a pattern that we can write an algebraic representation for again, but I always like to start with in your own words. What are you noticing happening to your original points when they were totally rotated upside down, 180 degrees clockwise? We didn't switch anything. We just negated the x and y values. And that trick will work every time you want to do a 180 rotation. So negate x stays there, y stays there, but they are both negative. So guys, now you have kind of like a cheat sheet. Whenever you need to do a 90-degree rotation, this is the trick. Whenever you need to do a 180, this is the trick. So last thing is a 270. If you have to do a 270, remember the original triangle was over there in the first quadrant. There's 90, there's another 90, there's a third 90. 3 90s is what makes up 270. So getting your image to be seen on your little transparency sheet is helpful, and then getting those coordinate points off from there. Take a second. You can pause the video right now so you have time to do this yourself. Take a second, record the image that you see for this 270. Come up with, at least in your own words, what you think is happening with the pattern, and try the algebraic representation also. So go ahead and pause, try this one on your own. Okay, so hopefully you saw that this A prime is at -1, 2, B prime is at -1 up 6, and C prime is out -7, because remember this one has to be turned completely on its side. And the rule is you negated x, you switched it with the points like we did the last time. But again, this is what it would look like with your algebraic representation. The y value got negated, and yes, you did switch places. So with this information, you can do questions like this on the bottom. This says if you're going to identify what happens, 9, 8 would be up in this first quadrant. When it rotates to 8, -9, it's only rotating 90 clockwise to get down into that second quadrant. We also noticed that they switched the x and y value, and this original x value got negated, just like what we talked about with our clockwise 90-degree rotation when we looked at it. -4, 5 would be a point up here in the second quadrant, and if it rotates to -5, -4, it means it moved counterclockwise 90, or you could say 270 clockwise. And the last one has to be a 180, because if you look, they took the original coordinates and they just negated them. The opposite of -6 is +6. When we negate -1, we get +1. So that's how we know it's 180. You could say clockwise or counterclockwise. The very bottom, we have questions about preserving or changing stuff. Orientation is just the order of the letters that gets preserved, and of course the size gets preserved. When we did our rotation, the size of our shape didn't change, just the way it was situated on the graph got turned. What you're going to do now is you're going to take the other half of your note sheet, you're going to go through the examples, and you're going to try applying these tricks that we learned about, and then check with me so I can help you if you are struggling with this.